VA.
All right. Okay.
Yeah.
We'll start with CCIE Enterprise. Okay.
Okay, cool. 100% list.
Yeah. So first of all, I want to take you through the CCIE Enterprise Lab
Yes.
syllabus. All right. Go to cisco.com. Learn certification exam list. Can you see the Chrome?
Yeah, I can see that.
And here we have the CCIE lab exam. Yes.
Yes.
CCIE Enterprise. So you know that for CCIE lab exam, CCNP and core is required.
Yes.
If you haven't done your CCNP and core, you would not be able to book your lab exam for the enterprise.
Yeah. So I already attempted the lab twice. So I'm still have a valid. I think it's expiring 2023, but a valid license to sort of go write the lab.
Validity is of 3 years for CCNP and core. Okay.
Yeah. Okay.
Yeah. So let me download this. So now you can see it, right?
Yeah, I can see it.
CCIE Enterprise version 1 lab exam.
Yes.
So the first section is dedicated to network infrastructure, which includes layer 2 and layer 3 technologies. In layer 3, you know that we have the routing protocols basically. In routing protocols, we have AIGRP, we have OSPF, and we have BGP. Okay. In layer 2, we have STP. We have
the channel.
Ether channel.
BTP maybe.
Yeah. Yeah. So now you can see in 1.1 is talking about switched campus.
Yeah.
What is MAC address table, right?
Yes.
What is error disabled recovery? What is layer 2 MTU? So basically we have 2 types of MTU. One is layer 3 MTU. Next is layer 2 MTU. And MTU stands for maximum transmission unit. So it's keep changing. All right. Layer 2 protocols, CDP, LLDP, UDLD. You know the difference between CDP and LLDP?
Yes, CDP is Cisco proprietary.
Yes.
LLDP, it's an open standard.
It's an open standard protocol. Very good. So basically, these 2 protocols were designed to discover the connected devices.
Yes.
And then you have the VLAN technology.
Yes.
We have access port, trunk port, VLAN, then we have native VLAN, manual pruning, VLAN database, normal range and extended range, voice VLAN and VTP. So basically, if you talk about types of VLANs, we have 2 types of VLAN. We have data VLANs and we have voice VLANs. If we talk about the range, then we have standard and extended range of VLAN.
Extended, yeah.
So VLAN is a 12 bits number. So 12 bits number means 2 to power 12 is equal to 4096. So in
Okay.
standard we have 121023. Sorry, 121005.
02 or 5, yes.
And here we have 100624094. You'll say, what about 0 and 4095?
Yes.
Because we cannot go to 6 because we start from 0. So that's
0.
why it is 0 to 4095.
Yes.
So basically 0 and 4095. These are two reserved VLANs.
Okay. Yeah.
That's why I'm not counting these VLANs in standard or extended range.
Extended. Okay.
After that, Ether channel. This is a very
Yes.
important topic in network design and in a network as well. So you know that Ether channel is a link bundling technology, right?
Yes.
Yeah. So this is switch 1. This is switch 2. And we can bundle links together to increase the total throughput, right?
Yeah.
So now we can see in Ether channel, we have four links of fast Ethernet.
Yeah.
So 100 Mbps, 100 Mbps, 100 Mbps, and 100 Mbps. So what we supposed that it will connect 4 links together, we will have total 400 Mbps bandwidth,
Yes.
right?
Yes.
And throughput would be double because we have full duplex links.
Yes.
So I can send 100 Mbps and I can receive 100 Mbps.
Yes.
So together it would be 800
Mbps.
But by default, STP will not allow this.
Yes.
Right?
You need to block. Yes, you need to block some ports of connections.
Yeah. All right.
Yes.
So for link bundling, we have on mode to make the configuration.
Yeah.
Either we have PAGP or we can use LACP.
LACP.
If we use PAGP, we have auto and desirable 2 modes.
Yes.
In LACP, I have active and passive.
Passive, yes.
All right.
Yeah.
Okay, Babu. Then in Ether channel, one more important topic, which is load balancing. How the traffic load will be distributed among the links. Like if you bundle 8 links and switch receives the traffic, so switch has to load balance the traffic on the links. So how a switch will decide that which interface will be used? For that, we have a load balancing algorithm, which is being used in the network. Okay.
Yes.
Then we have Ether channel misconfiguration card. This feature is by default enabled.
Okay.
Right. Basically, what is the problem with on mode? If this is a switch 1 and this is switch 2. Okay, Kavasto?
Yes.
And we have 2 links here. If you will configure on mode on this side, switch 1 will bundling its own links, and this link will start acting as a single link, right?
Okay.
But I haven't done the configuration on switch 2 side.
Okay.
Interfaces of switch 2 are still working as an independent links.
Okay.
So this will create a loop in the network because links are bundled from switch 1 side, but not from the switch 2 side.
Switch 2 side. Okay.
To detect this situation, we have a feature known as Ether channel misconfiguration guard. All right.
Okay. Yeah.
It is by default enabled, but it is always recommended that please do not configure Ether channel using on mode. All right. Okay.
Okay. Understood. Yes.
Yeah. Yes. So then we have STP, right, Kagosto?
Yes.
In STP, we have CST, we have PVST, we have PVST plus,
Okay.
RPVST plus, RSTP, and
MSTP.
MSTP. Then we have switch priority, port priority, path cost, STP timers. Because the first thing in STP is STP elections. If I have, for example, if I have 3 switches,
Yeah.
all of them are connected in a looped topology. This is a physically looped topology, right?
Yeah.
Like from switch 1, you can reach to switch 1.
Yes.
From switch 2, you can reach to switch 2. This is a physically looped topology. So we need STP here. And what STP
Yes.
will do? STP will block the
One of
redundant
the
links.
links.
But before doing that, an election will be occurring here, and in which we'll elect the root bridge. Then all other switches will become non-root, right?
Yeah.
Few ports will become DP, one of them will become RP, DP, for example, RP, and one of the links will become alternate. Then we have STP states. So for as per STP state, DP port will remain in forwarding state. RP port is also in forwarding state, forwarding state, forwarding state, forwarding state, and this link will remain in blocking state. All right.
Okay.
So this is how STP will prevent the loop. But you know that there are multiple things involved.
Yes.
But how root bridge will be elected, how root port will be elected, how designated port will be elected, how much time will be taken by this process. All of this stuff is included in STP, which you've already done in your CCNP core, right?
Yes. Yes.
Then we have routing concepts, not routing protocol, basically routing concepts. Because before going the routing, you must have the understanding of administrative distance, that what is an AD value, what is VRF, and what is VRF light. Static routing, policy based routing, right?
Okay.
And you have VRF aware routing with any routing protocol, route filtering, manual summarization, redistribution, routing protocol authentication, bidirectional forwarding, detection.
Yeah.
Then first protocol is EIGRP. Okay.
Yes.
Now EIGRP, again 2 types. Classic mode EIGRP and
named mode.
Named mode EIGR. So in CCIE lab, you'll see you have to configure classic mode EIGRP as well as named mode EIGR. So you can see best part decision, RD, FD, FC, successor, feasible successor. Then you have classic metric and
Wide metric.
wide metric is used in named mode EIGRP. Classic metric is used in classic mode EIGR. Then operations, what is general operations, what is topology table, packet types. Like in EIGRP, you have hello, you have update, query, reply, acknowledgement, SIA query, and SIA reply, right?
Yeah.
Then you have stuck inactive, graceful shutdown, EIGRP load balancing, equal cost, unequal cost, add multiple path or add path. Add path is a feature in EIGRP. Okay.
Yeah.
Then EIGRP named mode. The named mode configuration. Fast convergence, query propagation boundaries, single hoop, leak map, EIGRP stuff with leak map. Then OSPF, version 2 and version 3.
Yes.
So in OSPF, we don't have types. In OSPF, we have versions, version 2 and version
3.
Adjacencies, network types, area types, path preference. Then we have operations. Again, the same thing, general operation, graceful shutdown, and TTL security mechanism. Optimization, convergence, and scalability. Metrics, LSA throttling, SPF tuning, fast hello. LSA propagation control, stub router, loop free alternate prefix suppression, because we have to cover OSPF as well. So OSPF version 3 is already completed in CCNP, right? Maybe you have idea about OSPF version 3 as well. Yeah, so I know for it, we use it for IPv6, and it has more security features. And the version 2 doesn't support IP version 6. That's why we have to configure version 3.
Yes, version 3, yes.
Yeah. Okay. Then BGP. Now BGP is very important for CCIE lab.
Yes.
And I think BGP is not much covered in CCNP. In CCNP, we have a very basic introduction of BGP, border gateway. Network engineers are like very fascinated by BGP. Okay, BGP is a very big protocol. BGP is mostly used in service provider networks, right?
Yes.
But BGP, you can say, is a dream protocol for every network engineer.
Yeah.
Because BGP is responsible for maintaining the internet routing table, right?
Yeah, yeah.
Because we know that the internet routers are having very, very big routing tables. Big routing table means They have thousands of network entries in their routing table. They have to advertise networks, they have to receive networks, then they have to decide the best path. So BGP is designed for that. But mostly people do what? They always criticize OSPF and EIGRP to glorify the BGP protocol, right?
Yeah.
But see, EIGRP and OSPF was not designed for that purpose. So personally, I never relate EIGRP or OSPF with BGP because BGP is
Yes.
designed for different types of network, like big size routing table.
Yes.
And EIGRP, OSPF were designed for the enterprise networks, basically.
Yes.
So it doesn't make any sense to compare these protocols like IGP and EGP.
Okay.
But for CCIE perspective, your BGP is important. Okay.
Yeah.
So in BGP, we have two types of neighbor, IBGP and EBGP.
EBGP.
If R1 and R2, on R1 I am running AS100, on R2 I'm also running AS100. This is R1, this is R2. I'm running AS100 and I'm running AS200 here.
Yeah.
So the neighborship would be IBGP, and here the neighborship is
EBGP.
EBGP. All right.
Mm-hmm.
So first thing that you have to enable BGP, then you have to configure the neighborship. Then you'll discuss how routes are advertised in BGP, what are the path attributes, route summarization, route filtering, route redistribution, path manipulation,
Mm-hmm.
right?
Yeah.
Yeah. So you can see path selection, attribute, best path selection, load balancing, routing policies.
Mm-hmm.
Then AS path manipulation, local AS allows AS in remove, private AS prepend,
Yes.
regular expression. BGP is a very big protocol. We will be covering it. Don't worry. Okay.
Okay. Yeah.
I will not be I'm not very much focused on the switching part, right? You have done switching in
Okay.
CCNP and that's enough.
Okay.
But in CCI, we will focus on the routing part. Like I'll be discussing BGP in detail. Okay.
Okay. Yes, that's good.
Again, multicast.
Yeah, that's a problem for me.
But don't worry, I'll make it easy for you.
Okay.
Okay.
Hello, Amit.
Yeah, I'm here.
Oh, sorry. I thought maybe my connection is down. Okay.
Yeah. multicast. So in CCNA, we learn about 3 types of communication. We learn about unicast. Multicast. And we have the broadcast. The definition is very easy. Unicast is one sender and one receiver, right?
Yeah.
Multicast one to many. And broadcast one to
any.
all. One to all.
All, yeah.
So the first thing is that sender is always unicast.
Okay.
Sender is always unicast. But the problem is in the destination. We have 1-to-1, which is very easy to identify, right?
Yes.
If I say I'm Amit and I want to talk with Kagostro, then it is very easy to understand or very easy to define. Source is Amit and destination is Kagostro.
Yeah.
If I have to do the broadcast, I have like 10 people around me, right? I can say listen all. It means all of them would be listening to me. Problem is with multicast, one to many. It is very difficult to define the destination machines in case of multicast.
Yes. Yeah, I think it's coming. Yes, it's fine now.
All right. So this whole section 1.6 is dedicated to multicast. Then section 2, which is completely dedicated to software-defined access. 2.1 stands for SD access. So SD access is for LAN automation. It is for LAN automation. Okay. And just a second. And in section 2, we have SD-WAN as well, which is for WAN automation.
Okay.
I think you know about SD access and SD-WAN a little bit, not that much.
Yes. Yes.
But we will be covering it. What is SD access and what is SD-WAN?
SD-WAN, okay.
Right.
Yes. 100%.
It's an interesting technology. Personally, I love LAN automation and WAN automation technologies.
Okay.
Because there's so much to learn, but before learning this, your basics must be clear.
In place, yeah.
Yeah.
Okay.
Then we have transport technology and solutions. In this, we have 2 technologies important in the point of view of the CCIE lab and as well as normal in day-to-day life. MPLS stands for multi-protocol label switch. DMVPN stands for dynamic multi-point virtual private network. Right?
Yes.
So in MPLS, we have MPLS operations, we have layer 3 VP, which we have, because MPLS is just a term. You know who is the real hero? The real hero is LDP.
LDP, yeah.
Label Discovery Protocol, because MPLS is just a name. MPLS is not a protocol by itself, right? So the main hero is LDP, Label Discovery Protocol. Then in section 3.2, we have the DMVPN. Again, DMVPN is not a protocol by itself. In DMVPN, you'll see we will be having the GRE, NHRP, and IPsec, IP security. Okay.
Yes.
Then infrastructure, security, and services, which is 15% of the syllabus. Security and services. In services, we have DHCP, right? NTP, FHRP. Have you listened about FHRP?
Yes, first
redundancy protocol,
yeah.
right? In which we have HSRP, we have VRRP, and we have GLP. Then you can have SNMP here, and you can have ACLs. So you can see in first thing is device security on Cisco ICE XC, control plane policing and protection, which is known as COPP. And then AAA, authentication, authorization, and
accounting.
For this we require
IC, okay.
ICE, Identity Service Engine. Then network security, in which we have VLAN ACL and port ACL. Storm control. So basically here it is talking about layer 2 security.
Yes.
You can see DHCP snooping, DHCP option 82, IP source guard, dynamic ARP inspection, which is also known as DIA. Port security, okay. And
private VLAN.
Private VLAN. Then we have routing security features. IP version 6 traffic filters, IP version 4 ACLs, and URPF, which is again a security feature. Unicast, reverse path forwarding. IPv6 infrastructure security features. Again, IPv6 is an important part. What is RA guard? What is DHCP guard? What is binding table, device tracking, ND inspection and snooping, and source guard? And 4.2D, in which we have IEEE 802.1x. So basically, this, what is this? This is your switch. All right. Again, this is another switch. And for example, we have ICE here. So whenever a user will be trying to connect in the network, what we will be doing, we'll deploy 802.1x here. Means
Yeah.
This user will try to connect. Switch will ask for the username and password. All right.
Yeah.
If the user is not authenticated, this port will remain in downstream, or you will not be able to forward the traffic.
Yes.
So what switch will do? Switch will go to ICE, and ICE will authenticate the user. So switch will say, okay, user is admin, password is Cisco. Is it a valid user? ICE will look up into the database. And if this is a valid user, it will say, okay, allowed. Access, accept. Otherwise, access rejected. System management. Port 3. So these topics are also very, very important for a network. Device management, console and VTY, SSH, SCP, REST config, netcon. So there was no such thing as netcon for RESTcon before 2020. But now you have to deal with these two protocols also. What is netconf and what is RESTcon? All right.
Yes.
Then SNMP, simple network management protocol. And in SNMP, you have three versions basically: version 1, version 2, and version 3. But you can see in CCIE, no need to learn about version 1. To learn version 2 and version 3 only. Then logging. Local logging, syslog, debug, conditional debug, and time steps. So now about logging, which we call system logs, right?
Yeah.
So actually, whenever we see that something is happening on the device, that thing can be so again, important part. And section 4.4 is all about the quality of service, right? End-to-end layer 3 quality of service using MQC, diffserv. So you have two models here, diffserv and intserv. COS and DSCP. COS stands for class of service. All right. Which is an old method. New method is DSCP. DSCP stands for distributed service code point. Differentiated service code point. Okay. Then we have classification, network-based application recognition, which is N-bar, marking using IP precedence, DHCP and host, policing, shaping, congestion management and avoidance, HQS, separate Ethernet link. So all of these things are included in quality of service section. Okay. I'm just taking you through the CCIE lab exam syllabus. All right. Then 4.5 network services. Please go through it. Sagosto.
Sorry, I was on mute. So it starts with the first up redundancy protocol, HSRP,
Yes.
GLBP, VRRP. Those are the
Yes.
three. HSRP is Cisco, and the other two are open standard. And redundancy using IPv6, RS, and RA. And then we use network time protocol, master and client authentication. The authentication process to the NTP server, DHCP on Cisco iOS, client server relay, and then we do the options. And then we select for IPv6 DHCP interaction, and stateful and stateless DHCP v6 DHCP v6 prefix delegation, IPv4 network address translation. There we've got static net and port address translation. Then we've got dynamic net. We've also dynamic pet. Then we've got policy-based net, policy-based pet, VRF aware net, VRF aware pet. Then iOS XE, VRF aware software infrastructure, which is new for me, this one. VES net, okay. Yeah. You can scroll down.
Yeah.
Okay, and then we've got a network optimization, IPSLA, and then you have ICMP probes, UDP probes, TCP probes, tracking objects, and flexible net flow. Okay. Then we've got network operations. We'll check under network operation.
So, see, here you have seen section 4.5, which is completely dedicated to network services, right?
Yeah.
We know that FHRP protocols are very, very important.
Yes.
If you have HSRP, GLBP, or VRR. 4.2, we have network time protocol, which is known as NTP.
NTP. Yeah.
Master client and authentication. 4.5, DHCP on Cisco iOS, client options, SLAT, stateful, stateless, DHCP version 6, prefix delegations. The net, static net, pad, dynamic net, pad, policy-based net, pad, PRF aware net, pad, and iOS XE software infrastructure net. So this whole section is dedicated to net.
Net, okay.
Then we have network optimization. IPSLA. Internet Protocol Service Level Agreement. Right?
Yeah.
You'll see that tracking object we will be using in VRRP. We will be using it in HSRP. We will also see IPSLA in HSRP and VRRP. How we can use these two features. Okay. Then network operations. Network operations, we have span, we have rspan, and we have ERSpan, and we have embedded packet capture. Okay. And then Cisco iOS XC troubleshooting tools, packet trace, and conditional debugger. Conditional debug, because basically what you can do, you can implement ACL with debugging.
With the lost connection there.
What?
Just lost a bit of connection. We are at network operations.
Yeah.
Yes.
Know about span, rspan, ERSpan?
Yes.
Swiss port analyzer, right?
Yeah. What mirror?
Port mirroring, yes.
Yeah.
So this is a user, and this is the port is connected with F0/1. So by configuring span, what you can do, you can ask to the Swiss to capture the incoming traffic or outgoing traffic, or both.
Both.
You can capture the incoming traffic, outgoing traffic, or you can capture both. Incoming and outgoing both, right? Okay. Then we have infrastructure automation and programmability. Data encoding formats. JSON XML.
Okay.
Automation and scripting. Programmability. Okay.
Yeah.
This is something very, very new. So basically in CCIE, you have two new topics. First one was here, section 2 and section 5.
Okay.
Basically, JSON and XML are two data formats. JSON stands for
JavaScript object notation. Okay.
And XML stands for
Extensible messaging language.
extensible markup language. Okay.
Markup language, sorry. Yeah.
These two, here mostly see these are two data formats in APIs.
Okay.
Then we have automation and scripting, EEM templates, Castle, in which we have Linux environment, CLI Python module, and EAEM Python module. And then last we have the programmability. So in programmability, you'll have to deal with Python. We don't have any other language here. We don't use Java or any other C or C++. We use Python in network automation. Okay.
Okay.
You will be seeing that we are using vmanage. You know what is vmanage? It is basically Viptela solution, which is used for SD-WAN. Okay.
SD-WAN, yeah.
In which we have three controllers. We have vmanage. We have v1. We have v1. So basically, you'll see that with the help of APIs, we'll create Python script on the vmanage. We can push that to the routers or to the switches.
Okay.
Then you can say same thing we have to do with the DNS center also. Then we have to interaction with Cisco iOS XC API via netconf or via restconf using Python libraries. For this, you must have done your CCNA DevNet if you want to detailed understanding. Okay.
Okay.
Yeah. You can do that later on after your CCI.
Okay.
Yeah. This is the syllabus of CCI lab.
Okay, cool.
Yeah. Okay.
Okay.
If you have any question till now, please feel free to ask.
Yeah, so my issue, I guess, with the lab is, all this technology and concepts are sort of like combined into a single exam, and they try to test you on different technology in different cases. Like, for example, you find you get tested on AAA, but under the SDA section, for example. So I just maybe if you guys have a plan on sort of like maybe simulating a scenario similar to the exam with all the topics integrated. Like to test.
Sorry, but I didn't get you, Kaustu. Can
No,
you
I'm
speak
saying
a bit louder and a bit slow?
okay. No, I'm saying, like, do you have like a strategy
Yes.
of approaching the exam, since there's so many topics in the exam, but when you get there, they are sort of like congested into one. So are we going to learn the technology separately, or are we going to learn them together, maybe within a topology? Okay.
Yeah. So you know that our ultimate purpose is CCIE lab exam, right?
Yes, yes.
So what we will be doing there, I'll open a task.
Yeah.
We'll discuss what the protocol is involved, what are
Yes.
the things, and then we'll move to next task. Then we'll cover that topic particularly, and then we'll do the task. Okay.
The task. Okay.
We will be doing it like this or this way.
Okay.
Yeah.
Okay. Okay. Cool. No problem. No problem. And then in terms of material reference, are we going to use Cisco Learning online, or do you have material that I can reference for technology, for example?
For technology?
Yes, like material, maybe reading material, or do you have videos?
I can provide you the books.
Okay. Okay.
Yeah. Okay.
No problem.
Okay,
thank you.
Yeah.
Okay. No, that's it for me. It's clear. Let's get it going.
Can you see the MS Paint? Hello?
Sorry, I didn't get that.
Can you see the MS Paint file?
The file.
No, okay.
No.
I think now you can see it.
Okay.
Right?
Okay.
So first of all, we will start with layer 2 technologies.
Okay.
So I can show you the lab diagram, guys. Can you see the picture here? Wait a second. Now. Hello?
Yes, I can see the picture.
See, this is your headquarters.
Yeah.
Right?
Yes.
Then we have data center here.
Okay.
Then we have site here.
Okay.
Then if we go downstairs, we have BGP here. We have branch 3, we have branch 2, and we have branch 1. So basically, we have total 4 branches. We have data center and we have the headquarters.
Okay.
In data center, you can see we have the vSmart, we have the vBond, and we have the vManage.
Okay.
And we have the data center or DNS center as well.
Oh, yes, I see.
Yeah. So now you can see that I have the V edges here. So from here, I have to manage the V edges from the controllers located in data center.
Oh, okay.
So we have the network controllers, and network controllers can be deployed
On-prem.
On premises or
Cloud.
off premises. So basically off premises means cloud, or we can say our
data center. Okay.
Data center. So like in this topology, we have deployed our controllers in the data center and our network devices are located on the branches.
On the branches, okay.
Then we have the global SP here. So we have two service provider, internet service provider here and here. All right.
Okay.
So we will be starting with the headquarter first.
Okay.
Yeah. In headquarter, you can see we have switch, PC, host 11, host 12. We have switches, switch 101, we have switch 102. Right?
Okay. Yeah.
Yeah.
Okay.
So let me show you a sample question. Okay.
Okay.
Can you see it, the question?
Yes, I can see it.
So this is a sample question for the lab exam.
Yes.
Complete and correct the ether channel configuration between switches, switch 101, switch 102, and 110. So as you can see in the headquarter, we have switch 110, we have switch 102 and 101.
Okay.
So as per the question, what we have to achieve at the end of the task, all ether channel between switch 101, 102, and 110 must be up and operational, including all their physical
member links. Okay.
This is your switch 110. This is your switch 101, and this is your switch 102. So as you can see in the picture, we have two ports here, and two ports here.
Yeah.
Give me 1 minute. Now, in the task number 2, do not create new port channel interfaces. Reuse those that already exist on the switches. You know, the best part is that in lab exam, you get the pre-configuration.
Okay.
Sometimes, okay?
Yeah.
So now you have to create the port channel here between this switch, and this switch.
That switch. Okay.
When resolving existing issues, do not the pre-configured negotiation.
Okay.
If you'll see that they're already the ether channel has been configured and they are using PAGP. Okay. So don't configure LSCP over there, okay?
Okay.
If LSCP is configured, don't use PAGP, or if they have configured own mode. So please don't think, okay, own mode is not best, we should configure PAGP or LSCP, let me change it. No. If they have configured own mode, it means they want you to configure own mode. All right?
Okay.
They want you to troubleshoot the problem if your ether channel is not working.
Okay.
On ether channel, use a negotiation protocol, tune its modes of operation for the shortest link bundling time possible. Now this is a tricky question.
Yes.
So see, if they'll have to, like, if they'll say you, please run this protocol, CDP, LLDP, PACP, LACP, BGP, all right?
Yes.
So please don't expect such questions. They'll not tell you directly
Directly. Okay.
that what should be configured.
Okay.
Okay.
Makes sense.
Yeah.
Yeah.
So it is in this task, it is asking you to configure LACP, which takes
Yeah.
less time.
Less time to configure. Okay.
Configuring.
So, for example, with this question now, would you need to do LACP active on both sides so that we don't have, or you can do active passive, so that
You
you
can
don't have
do
a
you can do anything.
negotiation?
So what you want, yeah.
Okay.
If you'll do, you know that if you'll do active, sorry, passive,
Yeah.
Ether channel won't come up.
Yeah, it won't come up. Yes. Okay. Okay.
Then spanning tree protocol.
Mhm.
You have to run STP, and now you have two VLANs here. You have
Yes.
VLAN 2000 and you have VLAN
2001.
2001. Now for VLAN 2000, you have to manipulate the root bridge election. Maybe switch 110 is elected as the root bridge for VLAN 2000. So what it is asking to you, that switch 101 must be the STP
STP.
root bridge.
Yes.
So
Okay.
you know that root bridge election is based upon the bridge ID.
Yes.
And bridge ID is a combination of base MAC address plus priority. Base MAC
Priority.
address plus
Priority.
right?
Yes.
Base MAC address is always fixed.
Mm-hmm.
The only thing you can change is priority, which is by default 32768.
Yes. Yes.
If you want to configure switch 101 as the root for VLAN 2000, you have to decrease the priority value
To 0. Yeah.
to 0. And for VLAN 2001, switch 102 must be the root. So you have to go to this switch and you have to change the priority for VLAN 2000.
And 1. Yes.
See, the root must be elected based on the bridge priority. Yes, it must be elected on the bridge ID, because if we are going to change it.
Yes.
Because the base MAC address is tiebreaker here.
Mm-hmm.
Whenever two switches participate in STP election, first of all, they will compare their priority. If the priority will tie, then they'll use base MAC address, right?
Yes.
And base MAC address cannot be same for two switches.
Yes, exactly.
Yeah. Then, on the three switches, have STP perform cost calculation in 32 bits.
Arithmetic.
Now, again, it is not asking you to configure a protocol, LSC, sorry, PSEP, sorry, PVST plus or anything, right? It is saying that you have to configure an STP protocol which use 32 bits metric. So if we discuss in STP, we have sort method and we have long method. In sort method, we calculate 16 bits metric. Long method, we calculate 32 bits metric. Now, in lab, please don't start the configuration by reading the first task only.
Okay.
Read all the tasks first.
Okay.
Right?
Yes.
Read all the tasks first in given section, then start the configuration. Now you can see on 3 switches, use the rapid STP version and ensure that it can achieve rapid convergence on all intersection between
switches.
So like I said, we have CST, we have PVST, we have PVST plus. We have rapid PVST, right? We have RSTP and we have
MSTP.
So PVST, CST and PVST plus doesn't support the rapid convergence. It means we have only 3 options.
Yes.
Either rapid PVST or RSTP or MSTP.
MSTP, yes.
Right? Then in this and this. Now RSTP is an open standard. You know the problem is you cannot enable RSTP on Cisco switches. Now we have only 2 options, either rapid PVST or
MSTP.
But now if you see here, the task is talking about particular VLAN. If they want you to configure MSTP, they must be talking about
instances. Okay.
Instances, right? They would not be talking about particular VLANs. It means we cannot configure MSTP. So the only option is rapid PVST. They haven't given you anything like this that you have to configure rapid PVST.
Okay.
You have to find out.
Yeah.
Then on switch 110, prevent all current and future access mode interfaces from being affected by the proposal and
agreement process.
So on this switch, we have 2 users. By default, RSTP or RPVST plus sending proposal and agreement function. So what we have to do here, we have to configure these ports as access and we have to enable
port fast.
If you will enable port fast, switch will not send any proposal message on that particular interface or that particular Cisco. All right.
Okay.
It depends where your end users are connected. You have to enable STP port fast feature. This is the first task. So you're getting it right.
Yeah.
So you can see the Ether channel task is there. You can see the STP task is there. Let me show you one more.
So there's 2 tasks in one, sort of like 2 technologies in one task.
Yeah.
Yeah. Okay.
Right now we are not making any configuration, or right now we are not doing the lab. I'm just showing you that how you'll get the questions in the lab exam.
Okay.
So, finish it. Implement an FHRP mechanism, right?
Yeah.
On switch 101, switch 102, for VLAN,
2000.
and
2001.
according to this
requirement.
Okay. Use group number 100. See, group number is given. When you'll configure like standby, if you're configuring VRRP, you'll use the standby command.
Okay.
You have to use group 100 for VLAN 2000, and you have to configure VLAN group number 101 for VLAN
2001. Okay.
But right now we can't decide that we have to run HSRP, VRRP, or
GLBP.
That's why I've asked you to read the task first.
All of it. Okay.
Use the first available IP version 4 address in the subnet for the address of the virtual
router.
router. if you are using subnet, for example, 10.1.1.0/24. So what would be the first valid IP? 10.1.1. This IP address must be used as
the virtual IP.
For VLAN 2000, switch 101 must be the preferred
gateway.
For VLAN 2000, switch 102 must be the preferred
gateway. Okay.
So you know that we have a concept of priority there.
Yes.
By default, priority is 100 and bigger is better.
Okay.
So you have to change the priority to achieve this particular task. Read it. Do not rely on the IP version 4 addresses of the switches as a role tiebreakers, because by default, HSRP or BRRP elections are based on priority plus IP address. If priority will tie, the router with the highest interface IP will become the active.
Okay.
So the role must be determined by an explicit configuration. It means you have to change the priority value. You have to change the priority values. Then fourth section, each preferred gateway must monitor the reachability of both routers R11 and R12 using the loopback IP version 4 address of the routers by an ICMP echo.
Okay.
The reachability is to be verified every 5 seconds with a timeout of
400 milliseconds.
It means what you have to do here. The switch 101 and 102 is connected with R11 and R12, right? So you have to monitor these links.
Okay.
And that's why it is asking you to monitor R11 and R2 using the loopback IP version 4 address configured on the routers by sending an
ICMP echo.
This is known as tracking, right?
Yes, yes.
And this time you have to configure IP SLA here. The reachability is to be verified every 5
seconds.
Like we are in a session, so you are on mute, right? In every 5 minutes, I'm asking you, Kogosto, are you there? What I'm doing?
Yes, yes.
I'm just verifying that you are there, right?
Yep.
This is how you have to verify R11 and R2 reachability in every 5 seconds by sending ICMP message.
Okay.
With a timeout of
400 milliseconds.
In 400 milliseconds, you should get a response.
Okay.
A router must be declared unreachable as soon as it does not respond to 3 probes in a row. Means you send first probe, second probe, and 3 probe, and you didn't get the reply from the router. It means your router is down.
Okay.
If both R11 and R12 are declared unreachable from a preferred gateway, the other switch must be allowed to assume the gateway role. This is the main motive of FSRP protocols, right? Means, see, switch 101 is active for VLAN 2001, right? For FHRP. For VLAN 2001, switch 2 is active. If this switch is not able to reach R11 and R12, so switch 102 should become the active for VLAN 2000 as well.
Yes.
Right. We'll see it. Use the FHRP protocol that allows the virtual IP address to match the IP version 4 address of a member. Again, this is very tricky question. This is R1, this is R2, this is a switch. Okay, dosto. On this interface, I'm having IP address 10.1.1. On this interface, I'm having IP address 10.1.1. In HSRP, you have to choose a virtual IP address.
Yes.
And that virtual IP address must not be configured anywhere.
Yes.
There should be a free IP address, right?
Yes.
But what it is saying, read the task number 5 again.
So use the first protocol that will allow the virtual IP address to match the IPv4 address of a member router. Okay, that's yeah.
It means
so one
R1 and R2 are participating in FHRP protocols. and they are using 10.1 or 10.2.
Yeah.
So virtual IP address must be this or this.
Yes.
Now
Okay.
this thing is not possible in HSRP.
HSRP.
So it means we have to run
VRRP. Yes.
VRRP.
Okay.
Okay.
Hmm.
This kind of questions will be given in the lab exam.
Yeah. Very tricky. Yeah.
Yeah, very tricky. Any question for me? You can ask.
So let's say, for example, technology like GLBP and VRP can do the same thing. Will
No,
you be
GLBP is
penalized?
Cisco proprietary protocol.
Yes, yes. Yes.
GLB,
Okay,
in
okay.
case of GLBP, you should have a, you can say, a pre-IP address.
Yes, yes.
And
yes,
that IP
yes.
address will be used as virtual IP. Okay.
Okay.
Yes.
Okay. No, no, I can understand.
Yeah. Clear? So in switching, you'll see the task related to spanning tree. Okay.
Yeah.
You must have understanding of spanning tree. You'll see task related to ether channel.
Yeah.
And you'll see task related to DHCP snooping.
Okay.
And SVI, switch virtual interface.
Mm-hmm.
So we can go with a quick revision of STP first.
Okay.
So if I talk about STP,
Yeah.
in STP you should have the understanding of STP. Like first of all, what is STP?
Mm-hmm.
Right?
Yeah.
Why STP is required? Types of
Yeah.
STP protocols like CST, PVST, PVST plus, RPVST plus, RSTP, and MSTP.
MST.
Then STP, root bridge election,
Mm-hmm.
root
What?
election, DP election, right?
Yeah.
Then STP port roles. Like you have RP, you have DP, and you have alternate port.
Alternate. Yeah.
STP port states. In STP port states, you have
Forwarding.
disabled,
Okay.
okay, blocking, sorry, listening,
Oh, that's
learning, and
learning and forwarding.
forwarding. STP root port manipulation,
Mm-hmm.
STP, root bridge election, manipulation. All right.
Okay.
STP timers manipulation. All of these tasks.
Yes.
Which must be clear with all of these topics in STP. Right. Then in Ether channel. What is Ether channel? Configuration, on mode, PACP and LACP,
LACP.
load balancing, how to change balancing attributes, Ether channel, misconfiguration, guard, right?
Yeah.
All of these topics must be clear.
Okay.
So I hope you have the basic idea of all of these topics.
Yes, 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 yes.
Right, you have done your CCMP and core already.
Yeah.
So I will not be digging the details. I'll take you through all of these topics tomorrow.
Okay. Yes.
We'll cover STP and then we'll cover Ether channel as well. Okay.
Okay.
And see then
100%.
what? Hello?
Yes.
Yeah.
Yes, yes. No, I understood.
Any confusion here?
No confusion. I'll do some reading tonight, just refresh on the topics, and then
Then we'll meet you tomorrow. Okay.
tomorrow. Yeah.
So I think that's enough for today.
Okay. Thank you so much.
Right.
Amit. Yes.
So what I'll do, I'll send you this syllabus. CCIE
Okay.
lab exam. All right.
Okay. Okay.
Yeah.
Okay. Please. Yeah.
History. Yeah. This one.
Okay.
You can do what? You can mark the topics like this.
Yes.
Like this. That you're clear with this, clear with this, clear this, clear this. All right.
Okay.
You can mark all the topics which you are comfortable, and you can send it to me. That we don't waste your time on the topic again and again.
Yes. Yes.
Right,
yes.
because it doesn't make any sense if you're already familiar with the configuration, with the troubleshooting.
Yeah.
So you can mark all of those topics and you can send me. Okay.
Okay, I'll do that.
Yeah. So I'll share this syllabus with you in the WhatsApp group.
Okay.
Yeah.
Okay.
That's all for today. From my side, Kagostu.
Thank you. Come on. So
Are you-
tomorrow, same time?
What?
Tomorrow, are we meeting same time?
Same time, yes.
Okay, good.
So I hope you like the session, and that's all.
Yes, it was very good and comforting.
Yeah.
Because, I'm a bit relaxed again.
All right, bye bye. Have a good day. What time is there?
My side is 9:42.
9:42 a.m. or p.m.
AM.
Okay.
Yeah.
All right then. Have a good day.
Okay. Thank you, sir. See you tomorrow.
Yeah.
Bye.
Bye.
Yes.